Hello, I welcome you all for digital e-learning system. I am Dr. Srinivasa, Assistant Professor of Physics in IDSG Government College, Chikmagalur. In this video, I am going to explain some basic concepts of thermodynamics and zeroth law, which is a syllabus for first B.Sc students. So, in this video, I am going to explain some concept of heat and temperature and also some basic concept related to thermodynamics such as thermodynamic system, different types of thermodynamic systems, macroscopic and microscopic properties, physical properties of a system, thermodynamic state and thermodynamic state coordinates or variables, thermodynamic equilibrium, and finally zeroth law of thermodynamics. First of all, what is a thermodynamics? Thermodynamics is a branch of science which deals with exchange of heat energy between bodies and conversion of the heat energy into mechanical energy and vice versa. Thermodynamics is a branch of science or physics which deals with exchange of heat energy between bodies and conversion of heat energy into mechanical energy and vice versa, means conversion of mechanical energy into heat. Thermodynamics also deals with the transfer of heat energy. Exchange of heat energy means the transfer of heat energy from one place to another and conversion of heat energy into mechanical work or vice versa, the another definition. So next we will discuss the concept of heat and temperature. So you all know that thermo means heat, dynamics means motion. That means the thermodynamics deals with the motion of heat, transfer of heat from one body to another body or from one place to another place or one body to another body. First of all, what is a heat? You all know that in your lower classes, heat is a form of energy that produces the sensation of hotness or coldness. Heat is a form of energy that produces the sensation of hotness or coldness. When a hot body is kept in contact with a cold body, there is a transfer of heat energy from hot body to cold body. The energy transferred is called heat. So, heat is an energy that transfers from hot body to cold body when they are kept in contact. Heat describes the transfer of thermal energy, heat energy, between the molecules within a system and is measured in joules, that is SI unit of energy, and heat energy is also measured in calories. Heat is defined as the internal energy of the body in transit. It is also defined as the internal energy of the body in transit. Heat measures how energy moves or flows from one body to another body. An object can gain heat or lose heat, but it cannot have heat. So it can gain energy by supplying energy, and the object can lose heat by leaving heat energy to the another body, but it cannot have heat. Heat is a measure of change, never a property possessed by an object or system. Heat is a measure of change in temperature. Change means there is a change in temperature. Never a property possessed by an object or system. Next, what is the concept of temperature? So you all know that temperature is the degree of hotness or coldness of a body. Temperature describes the average kinetic energy of molecules within a material or system. So you know that when we supply heat energy to a system or a body, the molecules in a body moves randomly in all directions possesses some kinetic energy. The average kinetic energy of molecules within a material or system is described by a temperature and is measured in Kelvin, Celsius and also in Fahrenheit. These are the different scales used to measure the temperature. Kelvin is the SI unit of temperature, and also we can measure the temperature using Celsius and Fahrenheit scale also. It is a measurable physical property of an object. Temperature is a measurable physical property of an object, also known as a state variable or thermodynamic variable or coordinate. When two bodies are placed in contact, you know that the heat flows from the body at higher temperature to the body at lower temperature. So heat always flows from a body which is at higher temperature to the body at lower temperature. Therefore, heat is the thermal state of a body which determines the direction in which the heat will flow. It is related to how fast the molecules within a substance are moving. So, heat is the thermal state of a body which determines the direction in which the heat will flow. It is related to how fast the molecules within a substance are moving. It can be used to measure the degree of heat. So, you already know that heat is a measure of the temperature is a measure of the degree of heat. That is degree of hotness or coldness of the body. So next we will study what is thermodynamic system, surroundings and boundary. What is a thermodynamic system? A definite quantity of matter under investigation is called a thermodynamic system. A definite quantity of matter under investigation is called a thermodynamic system. The simplest example of a system is a gas contained in a cylinder. If you take a cylinder and fitted with a frictionless piston and contains some gas, that gas is a system. And also a quantity of matter or a region in a space chosen for study or the part of the universe that is at the center of attention in thermodynamics is called the system. So, system is also defined as a quantity of matter or a region in a space chosen for study or the part of the universe that is at the center of attention in the thermodynamics is called the system. Example, a cup of tea, a beaker of water, an engine, a human body is also a system. See here in this diagram, a cup of tea is there. So a cup of tea is a system. And a beaker containing water is also a system. Even a human body is also a system. So a definite quantity of matter, so under investigation, is called thermodynamic system. Next, surroundings. The mass or region outside the system or the rest of the universe is called the surroundings. The mass or region outside the system or the rest of the universe is called the surroundings. Here there is a system. Around this system there is a space or region or rest of this system is called surroundings. So human body is a system. So around the human body there is an atmosphere. That atmosphere is called surroundings. And the next one is boundary. The real or imaginary surface which separates the system from surroundings. The real or imaginary surface which separates the system from surroundings is called a boundary. There is a system and there is a surroundings, but there is a real or imaginary surface is there. This real or imaginary surface which separates the system and surroundings is called a boundary. So in this slide we know that what is a system? That system is used to investigate a certain quantity. So a matter, a certain quantity of matter used to study is called thermodynamic system. The simplest example of a system is a gas contained in a cylinder. So around this system there is a region or space is called surroundings. The imaginaries or real surface which separates the system from surroundings is called a boundary. There are different types of systems: open thermodynamic system, closed thermodynamic system, and isolated thermodynamic system. We'll study one by one. So what is open thermodynamic system? A system which can exchange both the matter and energy with the surroundings is called an open system. A system which can exchange both matter and energy, very important, matter and energy with the surroundings is called an open system. Examples: an open cup of tea. Here there is a cup of tea. In that cup there is a hot tea. So here there is a transfer of both matter and energy. Transfer of energy means transfer of heat energy from tea to the surroundings. Then what is the transfer of matter? So matter, you know that solids, liquids and gases. Here from the hot tea the vapors are coming out to the surroundings. That means the flow of vapors of water and tea. So the flow of vapors of water means there is a transfer or exchange of matter. So any system which can exchange both the matter and energy with the surroundings is called an open system. So another example is an air compressor. So air at low pressure enters and air at high pressure leaves the system. Here in this diagram we can also easily understand what is an open thermodynamic system. An open thermodynamic system is one in which it can exchange both matter, mass and energy. So there is a transfer of or exchange of mass, yes. There is an exchange of energy, yes. So another example, air compressor. So air at low pressure enters and air at high pressure leaves the system. So transfer of matter is air, and heat energy also, there is a transfer of heat energy in the air compressor. That is, there is an exchange of matter and energy with the surroundings. So what is open thermodynamic system? We learned in this slide. Next, what is closed thermodynamic system? A system which can exchange only energy but not matter with the surroundings is called a closed system. A system which can exchange only energy but not matter with the surroundings is called a closed system. For example, a cylinder containing a gas having a conducting wall. Here there is a cylinder containing a gas. In a closed thermodynamic system, there is a exchange of energy. That is, exchange of energy, yes, but there is no exchange of mass. So exchange of mass is no. So only it transfers energy but not matter or mass. So a cylinder containing a gas having a conducting wall means, so heat energy can transfer from system to surroundings through a conducting wall, but there is no transfer of matter or gas. Next one is isolated system. What is isolated system? A thermodynamic system is said to be isolated if it does not exchange both the matter and energy with the surroundings. Very good example is thermos flask. In thermos flask, heat remains same. It does not exchange heat energy from system to the surroundings and also matter. So, three systems. One is open thermodynamic system. So, it exchanges both matter and energy. The second one, closed thermodynamic system. It can exchange only energy but not matter. The third one is isolated system. Isolated system is a thermodynamic system which does not exchange both the matter and energy. A good example is a thermos flask. Next, different kinds of walls or boundary we can see. So there are two walls. One is adiabatic wall and the second one is diathermic wall. The exchange of energy between the system and surroundings occur either thermally or by doing work on the system. The exchange of energy between the system and surroundings takes place either thermally or by doing an external work on the system. So, adiabatic wall. Adiabatic wall is an insulating wall, can be movable also, that does not allow flow of energy or heat energy from one system to another. Adiabatic wall is an insulating wall. Insulating wall means it does not exchange heat energy from system to the surroundings or from one body to another. Next one is diathermic wall. Diathermic wall is a conducting wall that allows energy flow, that is heat energy, to flow from one system to another or from one system to the surroundings. So diathermic wall is a conducting wall, whereas adiabatic wall is a insulating wall. Very, very important. So adiabatic wall does not allow or exchange heat energy from system to surroundings or from one body to another body, whereas diathermic wall is a conducting wall. It can exchange energy from system to the surroundings or from one body to another body. Next. So, macroscopic and microscopic properties of the system. The behavior of the system can be described in terms of macroscopic and microscopic properties. The behavior of the system can be described in terms of macroscopic and microscopic properties. What are the macroscopic properties? Physical macroscopic variables can be mechanical, material or thermal and can be described as and have the following properties. Physical macroscopic variables can be mechanical, material and also or thermal. So they are described the gross characteristics of the system. Macroscopic properties can be described or describe the gross means total characteristics of the system. These properties can describe the gross or overall or total characteristics of the system and can be measured directly in the laboratory. We can measure the macroscopic properties in the laboratory directly and can be directly experienced by our sense of perception. We can experience the sense of perception. So, for example, temperature, pressure, mass, volume, internal energy, entropy, etc. These are all examples of macroscopic. Macro means big properties, big bodies. Macroscopic properties are not concerned with the structure of the system. So these are not concerned with the structure of the system. So can be directly experienced by our sense of perception. So these are all examples for macroscopic. Macro means big. Micro means very small, of the order of 10 to the power of -6 meter. Macro means it is of the order of 10 to the power of 6 meter size. So all these are the properties of the macroscopic properties. Example, very important: pressure, temperature, mass, volume, internal energy, entropy, etc. What are microscopic properties? Microscopic properties are those which describes the internal structure, that is atoms and molecules of the system. So you all know that atoms and molecules are very small in size. So these microscopic properties describe the internal structure, that is atoms and molecules of the system. So internal atoms and molecules describe the internal structure of the system. About these atoms and molecules are the microscopic properties. Micro means very small, of the order of 10 to the power of minus 6 meter. Microscopic properties cannot be measured directly in the laboratory. We cannot measure the size of the atoms and molecules in the ordinary laboratory. Cannot be experienced by our sense of perception. So we cannot see or observe, or we cannot experience by our sense of perception, that is atoms and molecules, that is the internal structure of the body. Examples: velocities, energies, momenta, even masses of the molecules of the gas. So these are all examples of microscopic properties. So masses, velocities, energies, momenta, etc. of the molecules of the gas. These are all examples of microscopic properties. We will discuss some more physical properties of a system. So properties of a system is a measurable characteristic of a system that is in equilibrium. Properties of a system is a measurable characteristic of a system that is in equilibrium. Properties may be intensive or extensive. So there are two kinds of system. So that is properties of a system. One is intensive thermodynamic property, and the second one is extensive thermodynamic property. We will study what is intensive thermodynamic property and the examples. Next one, what is extensive thermodynamic property and the examples for extensive thermodynamic property. First of all, what is intensive thermodynamic property? A property which does not depend on the amount of matter in the system, that is, they are independent of the amount of mass, are called intensive thermodynamic property. A property which does not depend on the amount of matter in the system, that is, they are independent of the amount of mass, are called intensive thermodynamic property. Examples are temperature, pressure, density, specific volume, refractive index, hardness, viscosity, surface tension, specific heat, etc. are all examples for intensive thermodynamic properties. So to measure the temperature, so the measurement of the mass could not require a property which does not depend on amount of matter. So the temperature measures the degree of hotness or coldness of the body. Again, pressure, the density of the substance. So etc. Extensive thermodynamic property. A property which depends on the amount of matter in the system and varies directly with the mass. Extensive thermodynamic property is that a property which depends on the amount of matter in the system and varies directly with the mass. Example: mass, volume, energy, entropy, enthalpy, heat capacity, again gives free energy, etc. So these are the extensive thermodynamic properties. Examples for extensive thermodynamic properties, and these property depends on the amount of matter in the system and varies directly with the mass. Next, thermodynamic state variables are thermodynamic coordinates. So variables like pressure, volume, temperature, internal energy, which determines the thermodynamic state, are called thermodynamic state variables. So to understand the state of any thermodynamic system, we have to measure the variables like pressure, volume, temperature, internal energy, etc., which determines the thermodynamic state, are called thermodynamic state variables. So what is a thermodynamic state? A thermodynamic state is the condition of the system at a particular time described by parameters of suitable set of values called state variables like pressure, temperature, volume, etc. A thermodynamic state is the condition of the system at a particular time described by parameters of suitable set of values called state variables like pressure, temperature, volume, etc. The condition of the human body is described by the parameters like pressure, temperature, urea, etc. at a particular time. Likewise, state of the system is also described by thermodynamic properties. Next, we will discuss thermodynamic equilibrium. Any state of homogeneous system in which any two of the three variables such as pressure, volume and temperature remain constant as long as the external conditions remain unchanged is said to be in thermodynamic equilibrium. A state of homogeneous system in which any two of the three variables where they are like pressure, volume and temperature remain constant as long as the external conditions remain unchanged is said to be in thermodynamic equilibrium. For the attainment of complete equilibrium, three conditions have to be satisfied. They are mechanical equilibrium, thermal equilibrium and chemical equilibrium. What is mechanical equilibrium, thermal equilibrium and chemical equilibrium? We will study one by one. A system is said to be in the thermal equilibrium if the temperature of all its parts is same as that of its surroundings. That means at every part of the system, the temperature should be constant and also it should be equal to the temperature of the surroundings. Then a system is said to be in thermal equilibrium. A system is said to be in mechanical equilibrium if there is no net force in the interior of the system or between the system and surroundings. If there is no net force in the interior of the system or between the system and surroundings, then the system is said to be in mechanical equilibrium. Then what is chemical equilibrium? A system is said to be in the chemical equilibrium if the chemical composition is same throughout the system. If the chemical composition throughout the system is same, then the system is said to be in chemical equilibrium. So what is finally the thermodynamic equilibrium? It is the state in which no spontaneous changes are observed with respect to time. And also the system is said to be in the thermodynamic equilibrium if it is in a state of thermal, mechanical and chemical equilibrium when the macroscopic variables do not change with time, that is pressure, volume and temperature. If the macroscopic variable such as pressure, volume, temperature do not change with time, then the system is said to be thermodynamic equilibrium. And also if three equilibriums such as thermal, mechanical and chemical equilibrium satisfy, then the system is said to be in thermodynamic equilibrium. Finally, zeroth law of thermodynamics. What is zeroth law of thermodynamics? Why it is not called first and second law? R.H. Flower formulated this law in 1931 long after the first and second laws of thermodynamics were stated, and so numbered zeroth law of thermodynamics. R.H. Flower formulated this law in 1931, long after the first law and second laws of thermodynamics were stated, and so numbered before the first law, that is zeroth law of thermodynamics. Statement. It states that two systems in thermal equilibrium with a third system separately are in thermal equilibrium with each other. If the two systems are in thermal equilibrium with a third system separately, then they are in thermal equilibrium with each other. That is, the zeroth law clearly suggests that when two systems, say A and B, are in thermal equilibrium, there must be a physical quantity that has the same value for both. What is that physical quantity which is having same for both A and B? This thermodynamic variable whose value is equal for both the systems is in thermal equilibrium is called temperature. So this is very important. Zeroth law of the thermodynamics gives the concept of temperature for the first time. Zeroth law clearly suggests that when two systems A and B are in thermal equilibrium, there must be a physical quantity that has the same value for both. This thermodynamic variable whose value is equal for two systems in thermal equilibrium is called temperature. That means if the two systems are said to be in thermal equilibrium, then their temperature should be equal. Consider two systems A and B insulated from each other but in good thermal contact with a common system C. Systems A and B will attain thermal equilibrium with a third system. Thus, if A and B are separately in thermal equilibrium with C, then temperature of the A is equal to temperature of the C and temperature of B is equal to temperature of C. This implies that temperature of A is equal to temperature of B. If TA is equal to TC and TB is equal to TC, then TA is equal to TB. That is, the system A and B are also in thermal equilibrium. So as you see in this diagram, there are three bodies A, B and C. Here A and B bodies are separated by insulated wall, whereas A and C and B and C are separated by a conducting wall. If the two systems, say A and B, separately in thermal equilibrium with a third body, then these two bodies are also in thermal equilibrium. If any two bodies are in thermal equilibrium with a third, say C system separately, A is separately in thermal equilibrium with C, B is also separately in thermal equilibrium with C, then these two are also in thermal equilibrium with each other. That is the statement of the zeroth law of the thermodynamics. To understand the zeroth law of thermodynamics, consider the two systems A, B and C. Here A, between A and C and between B and C, there is a conducting wall. Between A and B, there is an insulating wall. That means there is no exchange of heat energy. If A and B are separately in thermal equilibrium with C, then A and B are also in thermal equilibrium. Here the thermal equilibrium measurement is done by measuring the temperature of the three systems. If TA is the temperature of the body A and TB is the temperature of the body B and TC is the temperature of the body C, then if TA is equal to TC and TB is equal to TC, then TA is equal to TB. So, and also that is system A and B are also in thermal equilibrium. The zeroth law defines the concept of temperature, very important, which is a fundamental to the first and second laws. To understand first and second law of thermodynamics, the concept of temperature is very, very important. That concept of temperature is given by zeroth law. Hence, the law that defines temperature must have a lower number than the first and second laws. Hence, the name given zeroth law of thermodynamics. The significance of the zeroth law of thermodynamics is that it gives the concept of temperature. This is very, very important. The significance of the zeroth law of thermodynamics is that it gives the concept of temperature. So, I have used all these books as reference to make this video. Thank you for watching. Thank you once again. And also, all of you subscribe my video, and if you want to like my video. Thank you once again. And also, all of you subscribe this video and my channel to get the other videos also.